up.
During the takeoff acceleration phase, if one engine fails, the pilot tries to maintain the runway axis using the rudder and the nose-wheel steering, both commanded by the pedals. If the runway is slippery, the nose-wheel steering may not be efficient. If in addition the speed is low, the rudder lacks authority and the airplane deviates significantly from the center line. When the speed is higher, the deviation is reduced and may be acceptable. The minimum control speed on ground, or VMCG, is the speed at which, during a takeoff run with maximum thrust on all engines, it is possible to maintain control of the airplane using the pedals alone, without nose-wheel steering, when the critical engine is made inoperative with a maximum deviation of 30 feet. When performing the tests, the deviation may be higher than anticipated. To add a safety margin during the acceleration, the pilot follows a blue line on the runway on the opposite side of the engine to be shut down. He chooses one of the two lines at 5 and 10 meters from the central axis. These lines also allow him to maintain a precise trajectory. The test ends when, after reaching the maximum deviation, the airplane converges towards the initial trajectory. Then there are two options, either to stop the aircraft or to take off. Stopping the airplane is generally preferred. However, braking may be performed over a short distance with a significant brake temperature increase that may delay any following tests. Taking off with one engine inoperative is not a comfortable situation. However, the shut-down engine is relighted immediately and the risk of failure of another engine is extremely low. Landing is performed a few minutes later on a long runway without overheating the brakes. The following VMCG test can then be performed without delay. The choice between these two options is made according to the characteristics of the aircraft and the length of the runway. For the execution of a test, the pilot flying aligns the aircraft on the blue line, and he starts the acceleration with the engines set at maximum thrust. During the initial phase, he maintains the axis using the nose-wheel steering for a precise guidance. Then, at around 80 knots, the nose-wheel steering is disconnected. When reaching the target speed, the other pilot shuts down the engine with the master lever. As soon as he detects a deviation, the pilot flying applies full pedal deflection and maintains it until the airplane comes back towards the initial axis. It is the end of the measurement. The pilot stops the aircraft, setting the thrust levers to idle, then extending the thrust reversers and braking. The crew may also take off according to the procedure decided. In both cases, the test flight engineer immediately relights the engine using specific procedures given by the engine manufacturer. It is sometimes difficult to anticipate the VMCG value by computation or with simulator tests. One of the main reasons is the complexity of the assessment of the friction of the tires on the ground during this maneuver. Therefore, for the first test, a significant margin with the estimated VMCG is taken to shut down the engine. With a first cutoff 10 knots above the estimated value, if the VMCG is properly evaluated, the maximum deviation should not exceed 2 to 3 meters. For the following tests, the cutoff speed is decreased in small steps of 1 to 3 knots, depending on the results. When approaching VMCG, the progression in speed must be very slow, as the lateral control deteriorates quickly. One test point is performed just below VMCG in order to get a deviation above 30 feet and to be able to interpolate to obtain an accurate result. Shutting down an engine at maximum thrust with a master lever leads to a compressor stall with possible degradations. Therefore, these tests are carried out with an old engine, which will be sent back to the engine manufacturer for an overhaul after the VMCG measurement. The VMCG tests are performed without crosswind because crosswind creates lateral forces on the fin, which slightly modify the deviation. For a new program or with a different engine, a series of tests is performed. Usually, around 6 to 8 engine cutoffs are sufficient to obtain the result.